So continuing the ordinal job to be done, we're now going to consider intertemporal decisions and the discounted utility model. Here now the things you choose from, the prospects, they are income streams, as I call them. They specify for different time points, different money amounts you get. Sometimes you can choose either you get a big amount of money later if you save it in the bank, or you spend a smaller amount of money right now. That's the intertemporal decision. Or you must choose between two streams of salary or risky investment pay at a different time. There are many intertemporal decisions that we have to take. So now we're going to consider how do we do that, how much do we discount, things like that. Some notation, x0, x1, etc. denotes an income stream. We'll take month as time unit, and we say this is x0 euro in month 1, x1 euro in month 2, and so on. For simplicity, only positive amounts of money, and for simplicity, only finitely many non-zero amounts. You have only finitely many months to live. Samuelson, you heard the name before, a clever, brilliant guy. Here again, a big idea. He proposed constant discounted utility, a good model to work with. Here is the formula of the model. What you do when you evaluate such an income stream, for every money amount you take its utility, capital U, but you multiply by positive money amounts, discount factors. So here the notation delta positive is a discount factor, but usually delta is smaller than 1. That means that future income, future utility weighs less than present utility. You're a bit impatient. You rather have money now than in the future. So that's the discounted utility model, and it's a useful model for many purposes. No surprise to you what will come now. The ordinalists want a justification of that model, a preference foundation, and Koopmans gave a nice one. So he said this model holds if and only if you have all kind of preference conditions. And first of all, weak ordering, you know that would come, always necessary. Continuity, technical, I will not define. Monotonicity, that's a trivial condition more or less, the more money the better. But now there will be two interesting conditions, and I must say the first one to come now is usually considered not to be very convincing. Both normatively people say, I don't think rational people should behave that way, and empirically people know it's violated. So then you may wonder, why then do we bring it up? But it's for pragmatic reasons, that with the condition that we're going to discuss next, the formulas are quite tractable, we can do business. If we give up that formula, things become way more difficult. That's why often in the temporal choice for those, such as life, for pragmatic reasons, people assume it. Although also many people do study violations, and then models get very complex. People pull up their sleeves and do work on it. But in discounted utility, we do not. So here is that debatable condition. It's separability, or additive separability. And one reason that I explained the condition to you is it's important in many fields. I think economics students should know what separability means, but often in courses, students didn't hear about it before. It's an important condition in many fields, in consumer theory. In fact, in this Savage model that I told you before, it plays a big role also. So let me now explain it here for intertemporal choice, what it means. Look at the upper line and assume you have a preference. You prefer the left income stream to the right income stream. Something special, it happens at time point J. I printed that bold. That means the income time in time J, the two income streams give the same income, common income Cj. Now separability, the idea of the condition is if you choose, you consider only the time point where it matters. Time point where the two income streams give the same, then it doesn't matter what you do, and therefore we ignore those time points in our decision. Imagine that is your attitude. Then, because here you're ignoring what happens in time point J anyhow, you don't even look at this Cj. If we replace that common outcome Cj by another common outcome Dj, so then we get the lower line, then here in the lower decision, you do the same reasoning. You say time point J doesn't matter, so I ignore it. That means you don't even look at Dj. But then if you're not looking at dj or cj anyhow, what remains on the other time point is the same above and below. So if you have the mentality of ignoring common outcomes, the upper preference should be the same as the lower preference. If you ignore common outcomes, it should not matter what the common outcome is. So that's a separability condition. Already told you also in consumer theory, they consider it if you must choose between two commodity bundles, both give you 3 apples, then maybe you ignore that number of apples in your choice. And then whether it will be 3 both or 10 apples, both of them, doesn't matter. That's separability for consumer theory. Many fields it's studied and important. Now at first it may sound a bit plausible, where it doesn't matter, you can ignore anyhow. But if you think a bit more, I think for intertemporal choice, this condition is not really reasonable. For instance, to give you an example where it's not reasonable, or you can imagine that Cj is quite a low amount of money, Xj is a bit better than Cj, Yj is j plus 1 is much better than Cj. Imagine that Dj is a bit bigger than Cj. Imagine it is so much bigger that now Xj plus 1 is smaller than Dj. So it was bigger than Cj, but it's smaller than Dj. But here Yj plus 1 is still bigger than Dj. In that case, the person may reason, wait a minute, here something unpleasant happens. From here to here, I have a decrease in income. And I have a special aversion to decreases in income. I never want my income to decrease. The person has that attitude. He says, in the lower preference, here something unpleasant happens that I don't like. And it may turn into the person saying, now I prefer the right option to the left option. So that kind of reasoning, if you have a special aversion to decreases in income, then you will sometimes violate additive separability. In a way, the spirit of separability is that there should be no interaction between outcome, different time points. That the outcome Cj should not affect how much you evaluate Xj plus 1. That's in a way the spirit of separability. But in the example I just gave, that's violated because how much you like Xj plus 1 depends on what happened before. If it is lower than before, you have a special dislike for it. And in intertemporal choice, it's very reasonable that such kind of interactions and other kinds of interaction between different time points matter a lot, so much that this condition is debatable. But as I said, often we make it for pragmatic reasons. In this course, we will discuss intertemporal choice several times more, but I will always take care that we only discuss it in situations where this condition plays no role. So in this course, we can get by ignoring it. But in other situations, you have to think more about it. But anyway, that's how we proceed. One more condition, maybe in a way more interesting, is stationarity. I'm going to define that a bit later. But anyway, these conditions give the theorem of Koopmans. So discounted utility can be falsified if and only if these conditions can be falsified, can be verified if and only, well, you know now how these theorems work, how they capture the empirical meaning of a model. And Koopmans succeeded in doing that for the model of Sam Wilson. So stationarity will be more, and it's more reasonable, still debatable. But I'm going to define it next. That will be studied a lot in this course. Also later we'll return to it. So now I define stationarity. Imagine you can choose between 2 income streams, and here they are. You prefer left to right. But then imagine that people say, oh, wait a minute, these 2 income streams, they will both be delayed by 1 month. So the first month is just C0, let's say business as usual. And then only 1 month later, start the 2 income streams. So consumption has been delayed. Will that affect your preference? And stationarity says, no, it will not affect your preference. Of course, you can imagine a situation where it will not happen, but with ceteris paribus, it's often a plausible condition. Note that in this condition, the decision time is always the present. That doesn't change. It's the consumption time that changes. If consumption income is delayed, that will not matter if it's the same for all the incomes considered. That's what stationarity says. you can repeat it if delaying something by 1 month never matters. You can do that repeatedly. And delaying something by 5 months, you just do it 5 times. Should not matter either. Therefore, the condition implies, if we have that preference that we already saw, then delaying by t months should not matter either. That is just implied by the condition. Let me give you an example. Imagine you can choose either during 1 year you have 100 euro per month extra in salary, or during half a year you have 190 euro per month extra. Second one, you get your money sooner, but in total you get less. So what do you prefer? Maybe if you're very impatient, you prefer the lower one. If you are patient, you prefer the upper one. Let's assume for now that you're patient. You say, I prefer the upper one. The bigger amount in total, I like more. I don't mind so much waiting a bit for it. And imagine that now they say, oh, wait a minute. This salary increase will not happen right now. Only in 4 years from now it will happen. So you can choose either in 4 years from now, you get 100 euro per month extra during a year. Or in 4 years from now, you get 190 euro per month extra, but only during half a year. And then, if you satisfy stationarity, your preference should not be affected by that. If right now you prefer one to the other, when it happens in 4 years, also right now you prefer that one to the other. That's an example of stationarity. That means in a way that you are as patient for future consumption as you are for present consumption. Your degree of impatience remains constant. That's a way of formulating the condition. Right, that was intertemporal choice. Now we go to welfare theory. That will be in the next recording.